You're listening to Randomly Type. Today, I'm joined by Max, our recurring guest.
Hello. I guess I'm going to say hi now.
Today, we chose a nostalgic theme. We are talking about old modems.
What do modems evoke in your mind, Jess?
Oh, it was like the introduction to the internet. Like, this is the first time I used the internet and I was discovering everything I could find on the internet. So, pretty much everything.
Did you ever connect to a BBS when you were younger?
I know the name, but I'm not sure what it means.
Okay, so, I was asking because you're a bit older than I am, and I was maybe hoping that you had connected to BBS in your life, because I haven't. And I kind of wish I did, but I was, I think, either too young to be around the time of BBSs, or I just never discovered them at the right time, right?
So what's a BBS?
So what I know of a BBS, and again, I haven't joined a BBS ever, it's kind of a bulletin board system in telephone form. So you would connect to this machine that would contain the BBS, the bulletin board, just like any forum, like a modern forum thing, but you would connect with people that are in your local area. So it's only people that are near you because you share the same phone infrastructure around you. So, right. I mean, you probably could connect to machines that are
further.
Yeah, but I'm not sure if that was frequent. I know that people use them to connect to people near them.
So it was before the internet?
I think so. I think that was like the first online communities through phone connections.
Oh, wow. Okay. I missed something.
Yeah, same. That's why I'm saying I wish I had connected to one in my life, but it's never happened. So,
do they still exist?
Well, I would assume they do. Like any nerd things, people tend to keep them alive in any different ways. So probably like ham radio operators, right, that sort of thing. I suppose it happens today as well. But I guess I kind of want to ride now.
Yeah,
I kind of want to find one tonight.
After the episode, I'll be looking for a BBS.
Yeah, same.
All right, so now what's the real subject?
So let's try to see what a modem is, right? Because we know we use them every single day, and nowadays anyway, at home, they're integrated into the router that we use for our access points. But typically in the earlier days of the internet, you would have two separate devices. You would have for your access point, your wireless access point, you'd have the router, which was
wired at that point.
Or wired at that point, exactly. And then you would have the modem, which was another, like a separate device that would be solely responsible for taking the phone connection and modulating and demodulating the signal, which is basically what modem means. Modem is a portmanteau of modulator, demodulator, which is basically the function of the device.
Right. So by modulating, you mean transforming the binary information to sound waves.
Exactly. And demodulating being the opposite. So you take the sound waves and back into the binary form.
Right. So you would modulate when you send data and demodulate when you receive data.
Exactly. And so both devices on both ends would do both functions. Right.
This means that we had a modem in our house and they have like thousands of modems in their servers farm.
I guess so. But I think in the earlier days when you would connect to the internet and you would hear the beep we heard earlier, you would connect to one other modem. Right. So it's a one-to-one connection where one does the modulating, demodulating, and the other does the same thing with the data they get.
So one thing that's really interesting is that today our connection are mostly over like fibers or cable. But back in the days, the only infrastructure was phone lines. That's why back in the days, it was over sound.
One thing I find interesting is that phone lines were designed to be able to carry human voice, right? Not binary data. So the range of frequencies that they would be able to support on those phone lines were roughly between 300 and 3,000 hertz. And that's it.
Which is pretty much the spectrum of a voice.
Exactly. But the devices maybe could have supported some more, a wider range of frequencies, but because of the limitation of the phone infrastructure, modems would have to play within that range, right? So one thing I noted while I was searching for the episode was even like 5 years ago in 2015, AOL, the company we know from like connecting to the internet with dial-up and everything, 5 years ago, they were still holding a 2.1 million user base of dial-up users.
That makes no sense. It's so big.
2.1 million people, I guess in the United States, are still connecting to those 56K modem connections to access the modern web.
Do you imagine that? Like loading a JPEG would take seconds.
I know.
Minutes.
It's crazy. And I wonder how many sites are just not available for those users, right? Some of them are probably just not loading whatsoever.
I'm pretty sure any big JavaScript applications, or like Gmail, YouTube, whatever, couldn't work with that.
Yeah, probably. And not only that, but also, who are these people? Like, I'm assuming they live in areas where broadband connections just don't go.
Right.
But then the other thing I found is some people wouldn't change their connection because it's, to them, that's all they need. Yeah, exactly. And they wouldn't want to do more. But I wonder what kind of websites do they visit now?
Maybe they don't. Maybe they just do emails.
Maybe. But even then, I remember being with my grandparents in maybe the early 2000s and trying to download one picture on it in an email. And it would take something like 30 minutes for a single image. And it was terrible, you know?
Well,
but
if you have time for it.
yeah, true.
Why not?
But literally, my grandparents would go and make a coffee while waiting for the image to download. It's another time. It was crazy. It was signs of another time.
I like that.
So maybe let's start talking about where modems originated from and how we came to have modems, right? Initially, when you would want to send information over the wire, which was the telephone network, you would send a telegram, which was with a device called the teletype. The teletype would use the RS-232 standard to communicate over phone lines, and each teletype would be physically connected to its modem, working over 110 baud per second, which was very, very slow.
That's nothing.
That's nothing. And then what that would allow is for the modems to call each other to establish a connection between the two teletypes. And what one person would type at one of the teletype terminals could be printed on a remote teletype located somewhere else. And there was no computer involved, all directly on the phone line. Oh. This was initially used for newswire services. So what you would find as, you know, the ticker news you see at the bottom of the TV things,
right.
That's what you would see there, or any air defense communications was also used. So U.S. Air Force needed a way to transmit hundreds of radar images to command centers during the Cold War, and that's where they turned to telephone lines to transmit information.
I know the US is pretty much everywhere in the history of the internet. I know they put so much money to build the internet and like do the technology and everything.
Yeah, and I think, is it the World Wide Web as well? That's ARPANET. So ARPANET was funded by the U.S. Army to be developed, and then we kind of got to the internet from there, I think.
Yeah, exactly. So the first real modems that we know of were like 300 bytes per second. And the latest one that you probably had at your house was 56K. So which is a big difference. But still, for our current standard, it's nothing.
It is nothing in that nowadays, the average US broadband speed is 11.4 megabits per second, which is around 200 times faster than dial-up, the 56K dial-up. So it was nothing. It really was nothing.
And today you can get connection of like 1 gigabit, which is...
And even on your phone, you can be not even connected to a wired connection and get crazy fast speeds. So
yeah.
We've come a long way from since modems.
Yeah, we'll need to talk about 5G at some point because those connections are fast.
Might be for another episode, though, because totally. There's a lot of stuff in there.
So let's go back to the sound we played at the beginning of the episode. Initially, a modem was just a computer connected to a telephone line. It was dialing the phone number of the other modem and sending a handshake to try to establish a connection.
And to be clear, the sounds we would hear, the beep, boop, doop, that sort of thing, it wasn't an indication by the modem that it was doing something. It was the actual data being sent over the wire that you would hear. So, I don't know. That's just fascinating to me that you would hear what was going on the wire while it was happening, literally.
What's really interesting is that you could disable the sound. There was like one bit made to disable the sound. But just, it was like that. Just, we kept the sound.
But no one ever bothered turning it off? Huh. I didn't know that. That's interesting.
But in fact, once you're finished your handshake, they trigger that bit, to stop playing the sound.
So you're telling me that I could have kept the byte on to keep hearing everything that would go on my phone line while I was browsing the internet?
That's not what I said, but I guess, yeah, maybe.
I didn't know that. I should have done that.
That'll be so noisy. Because at the end, when it's binary, you only get the
Sure, but it's not noise,
well,
right?
it's noise.
Well, you think?
Well, pretty much.
Oh man, I need to connect to BBS's and turn on that bit tonight.
Just finding the modem itself will be hard.
I think I still have one at home.
Oh, really?
Well, I'm pretty sure that we don't have nowadays they have this one device that does modem and
Right.
access point. I think my parents still have one where it's separate.
I still do that at my place, like for cable.
Right, exactly. So you could do that, no?
But no, because the cable connection is binary. It's not
Oh, that's
analog.
I have to go. Okay, I'll have to go to my parents-in-law. My mother-in-law's place has this phone line. They're still connected to Bell, so internet is through Bell. No cables, no nothing. So
Okay.
if they do have a modem, I should be able to play around with this. Oh man, this is gonna be fun.
Next Christmas party.
Exactly.
All right. So now let's talk about the first part of the noise, the dialing.
So that was all analog data, right?
Exactly. So this was encoded with DTMF, which stands for dual tone multi-frequency signaling.
So I tried something a couple of weeks ago with my own cell phone, and I tried to manually inject DTMF tones into my phone to see if it would pick them up. So I went into any sort of synthesizer and tried to overlay the two frequencies for like number 1 or 2, whatever, and try to play those into my phone while it was waiting for waiting to be patched, like waiting for
Yeah.
whatever. Didn't work.
Really?
Yeah. So either the lines are just not accepting this, or like it just didn't work.
Maybe the cell phone is not using that and it's like straight up binary now.
True. Although one thing I have to clarify is I was in the the voicemail thing when you can try to go into your voicemail, whatever, and say press 1 to hear your messages. That's where I was trying to do the DTMF signal for 1.
We should try on real landlines. I feel like it would work.
Yeah. Like you put a mic, speaker into the headset and then see what happens. Yeah, maybe.
So let's explain what's DTMF, right?
Yeah.
It's a protocol using the voice frequency band over the telephone line to encode numbers. When we used to press on phone numbers, so like 1, 2, 3, every number was doing its different sound.
And that sound was actually a combination of two different frequencies on top of each other.
So pure sine waves.
Exactly. And the way I've always thought about it is every column and every row like has their own frequency to be overlaid on.
So for example, the first column was 697 hertz. Here's postprod.js. What I actually meant was that the first row and not the first column was 697 hertz. And the first column was 1209 hertz.
And so when you look at any number on the number grid on your phone, what you can build is a combination of two frequencies based on the row and the column that your number is going to be in. So for example, if you go for number 5, it is in the second row and the third column.
Here's Future.js again. He meant the second column, not the third one.
So you're going to get 770 hertz for the low tone, and you're going to get 1,336 hertz for the high tone.
So when you mix both together, you get a unique sound,
which represents number 5. So then you could say that when you would punch number 5 on your phone, the two frequencies would be sent over the wire directly as normal sound frequencies. And the telephone system was responsible for splitting those apart back into the low tone and high tones and figuring out that, oh, this is a 5.
And the frequencies they chose was meant to be sure that we don't randomly produce those frequencies with our voice. So they're all tones that are not harmonies or like things that sounds good.
Also, I assume they're spread apart enough so that when you punch a 5 and there's something that happens on the phone line, you don't accidentally get a 4 and call someone else.
And in the past, this was all done physically. So there was no like...
Oh, you mean by the operators?
No. Like there was some physical machines that were able to like understand the tones.
Right, okay.
So it's before computers.
Okay, but wait, there is something I need to know here. You know this era where there were literal human beings plugging you into the right cables,
So
I guess?
this was pre-DTMF.
Okay, but then how did they know at that point when you would do the phone number?
You wouldn't. So at that time, you would pick up your handset and would ask the person. There was no like
Oh man,
no sound for that.
that's crazy.
Uh-huh.
So glad I was born later than that.
You need to talk with someone.
I don't know. I guess I expected that you would still do your number, but someone on the other end would know the number you punched in somehow, and then they would communicate you or patch you through the other.
Nah.
Wow. Okay. So you would say, "Hey, patch me through the mayor."
Or like punch me like to California. So now they would redirect you to the California
Wow.
people, and from there you could ask.
Amazing. That's amazing.
All right. So next step, answering the call. The other modem will receive the call and start talking with binary data. Because let's not forget that so far everything was analog.
But again, to be clear, that binary data was being modulated to be understood on the phone line, right? To be sent over the phone line.
Yeah, exactly. Previously, the DTMF was just like pure sine waves. On the spectrum, they were like flat lines. But now it's encoding one and zeros.
Got it. Makes sense. So what would be in that binary data? What would that data say?
They need a lot of information to get the final handshake. They would start with the V8 BIS common protocol, which is an old protocol they could use to create the handshake. And once they understand what they're saying, they could upgrade to a newer and better protocol.
So you could say that V8 BIS was like the launch pad for every modem to connect or to be able to talk to any other modem.
Exactly.
Okay.
And the V8 BIS was at 300 BPS.
Which is, again, very slow.
Yeah, but it's enough for the initial handshake. You don't necessarily need to go much faster.
Right. Because I assume there's not that much data to be shared.
Exactly.
Okay.
Afterward, we have echo suppression. So as we said previously, the medium for the connection is telephone lines, which were meant for human voices. So there was a lot of systems on the lines that were made to help communicate between humans. One of those was echo suppression. So the goal of echo suppression was to be sure that when you were talking, you were not listening back to your own voice like 0.5 seconds too late.
Which is super annoying. I feel like that happens even nowadays on either real phone lines, especially with Bluetooth when you're on a headset or any other remote device, and Google Hangouts.
Oh man, Google Hangout is bad for that.
It's terrible at that. But like, I'm sorry to say this, but Google engineers, I know you're doing your best to do your work there, but hey, it's one of the experiences that I know Echo exists in.
So one thing that we normally do is one person talk, the other person listen. So this
That's so true.
engineers were using that fact to disable one of the two lines. So if I'm talking, they would disable the line back. So I wouldn't hear what Max would be producing as sound. He shouldn't be talking.
So I shouldn't be talking. So what you're saying is if I keep speaking, I'm never going to hear about you.
If the echo suppression technology works, yes,
Which it should.
which it should.
Right. But does that mean also that modems would prevent full duplex communication?
Well, that's the thing, right? Because this was not at the modem level. That was at the telephone network computer system level.
Okay,
this-
so echo suppression was only a matter of like, do modems do anything with echo suppression, or they just benefit from it because of phone systems?
they don't benefit from it. For them, it's a problem because, as you said,
Right. Oh,
it
yeah.
prevent them from having a full duplex connections.
Right, makes sense.
Because this would mean that if we have echo suppression, only one modem could talk at a time,
Good
which
point.
is like theoretically half of the speed that you could achieve.
So modems were already pretty slow, but now they're even slower because we produce their not throughput. Well, I guess it's their throughput that they can actually send data over.
Right.
Interesting.
The solution was that there's some magical frequencies, just like with DTMF, that were meant to disable echo suppression.
So whenever you would send that tone over the line, you would disable echo suppression.
Exactly. So if you were to send 2100 or 2225 hertz signals, boxes in the middle of the connection should disable their echo suppressions.
And do they do that for the remainder of the call?
Yes, that's the
okay.
goal.
Okay. So you would do it once, and then it's removed for the
Exactly.
entire call.
The long tone you just heard was that frequency.
So the next part is establishing capabilities. So both modems will want to be exchanging connection technologies to support in a binary format. And to be able to do that, they're going to send both their capabilities multiple times so that they ensure that the other modem heard the technologies they support correctly.
I'm really surprised because with current technologies, we don't normally send like 6 times the same thing. I didn't find information of why it was like that.
To be honest, I don't know either, but I remember from a university course where we did this Hamming code encoding, where it kind of, while you send the information, you also send an additional layer of information to say, or like a man, what's the
ECC?
name? Yeah, well, that or the what is the other name? CRC.
CRC, yeah.
So you ensure that you have the right information by validating that it checks out, I guess. And so by doing that, I suppose it's a way to validate the info you have. But in this sort of setting, I assume they don't have a way to do CDC, like a
CRC?
CRCs. So they just send it 3 times and then they hope that the other got it right. I'm not sure, to be frank.
Yeah. And something really interesting also is that they send information about their line. So is it like an analog line or digital? Because I guess at the beginning it was all analog.
I suppose
like
so, yeah.
phone lines. But I guess that at some point, digital lines became more present.
Good point. But then if we're on digital lines, why are modems still needed?
I guess they're doing more than just the audio decoding and encoding, like the connection with the remote server and, modem.
So they'd be like just a terminal between you and something else.
Yeah, maybe.
And that's it.
That would be my guess.
Interesting. Maybe we're saying ridiculous stuff right now
yeah.
and we have no idea.
And one of the other things I realized while reading documentation, I read some documentation, is that the up link and the down link doesn't need to be on the same protocol. So this means, exactly. That's weird. Huh?
Really?
Yeah. So it means that you could be using something that's faster to download things and something that's slower to upload your information.
You would have the same modem use 2 different technologies?
Yes, one for listening, one for sending.
Wow. Okay. I thought one modem would use one and the other modem would use another technology, but now the same modem uses different technologies for uplink or downlink.
So one of the last steps is to send some signal at specific tones and listen for the difference you get on the other side. So you know if there's a quality problem on certain tones. By doing that, you'll be able to adjust and send the right tone.
Also, what it does is it provides a way for modems to tell the other modem how many decibels they should be sending over to the other device. So you're not going to be sending a signal that is too strong or that is too weak so that the other terminal can hear you fine, basically.
So you could say like, don't send a signal under 6 decibels.
Or not over 2 decibels, for example.
Because what's really interesting here is that it's the perfect mix between like audio engineering and like binary data.
So the second to last part is just training. Both modems are going to be sending over random data over to the other one so that they can learn how the other one sounds. And from there, they can better communicate afterwards. Once that's done, both are going to be disabling the outside speaker so that you don't hear whatever data you're requesting over the wire and sending over. And they're going to be sending actual data for you to use and process and download this episode in 47 minutes.
This means that once it goes silent, the connection at the beginning is done. So now it's the real data transmission.
And as we said earlier, it might be possible, though I don't know if it is, that you could disable this disabled speaker thing, and you would be able to hear everything that you're requesting over the wire. Not sure if anybody's done it before. Not sure if it's even doable. I'm sure it is. I'd be curious to hear what it sounds like. It's probably just random noise and whatever.
Gibberish that we cannot get.
Yeah.
I feel like it would sound a little bit like the last training part.
Yeah, just like noise,
Yeah.
basically. Hey, you ever heard, whenever you have these, any kind of setup of speakers where your phone, you would hear the binary data being transmitted over the air?
No.
Okay, so
What's that?
one thing that's happened to me a few times is, or the best example I think is in a car. When you're in a car, you have your FM radio going, and imagine you have your phone in your pocket. You can predict that a text message is going to be entering your phone or going to be notifying on your phone a few seconds before it actually notifies, because you can hear the cellular data being transmitted over the air and into
No
your radio.
way.
So you can hear that. I know I hear that a few times, and I've heard that a few times in my life. And another related thing is I used to have a pair of headphones, wired headphones, and I think I was very, very close to a radio tower, I guess, and I could hear the radio through my headphones.
Right. So I had the same thing when I was playing guitar with friends. I know with amps,
Right.
if we were to like take the jack and put it like in our ends or something, we would get the radio.
Yeah, that's so nice, right? But it's something related to that, I think, where the data you would hear is something like that, I guess, or not radio, but the one about the cellular example. You would probably hear these dun, 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 or something. I don't know how it would sound, but anyway, I found it interesting to have this sort of data over the air that you would hear in your ears.
I guess things that you didn't expect to become an antenna becomes an antenna.
Yeah.
Like in my example, with the jack becoming the antenna.
Yeah, or you are the antenna.
Oh, true.
You are the antenna because you're holding the thing, right? So you become, if you
Right.
put your arm up, then you just get a better signal.
Yeah, so I was the antenna.
You were the antenna, yeah. And I guess in the car example, then the car was probably the antenna as well.
Yeah, probably.
right? Because it was connected to the actual antenna. But if the antenna is metal and it's connected to the chassis of the car, then probably the car is the antenna as well.
Yeah.
So cars are computers, but they're also antennas nowadays.
Exactly. All right. I think that's everything we had for this special episode on modems.
Thank you for joining us, and we'll see you next time.
Is there somewhere on the internet that listeners can find you?
Oh, I'm on, man, what a question. So I'm on Twitter. My last name and first name are very hard to pronounce in English. So if you're a French Canadian, I'm going to say it in French Canadian. That's Vaillancourt Max, all in one word. And if you want to say it in English and you want to try to decipher that out, that's Vaillancourt Max. So again, in one word. It's terrible to say in French. Jess is laughing right now. It's just the worst thing to try to say in English. But it's probably going to be in the show notes. I guess Jess is going to put that there.
Sure.
So Twitter, anything else is going to be a personal website, but really Twitter is probably the best place to check me out.
All
So
right.
thanks for the invitation, Jess.
Thanks for doing all the research.
Well, we were both. Like, both of us did it.
All right. See you soon. It's me again, Future JS. The coronavirus changed a lot of things for Lance and I. For example, where we were recording our episodes got closed for at least some weeks. So we don't know when we'll be able to produce the next episode for you. So we're still talking about how we'll do it, but for now, maybe you don't expect an episode in 2 weeks. Anyway, stay safe.
This podcast is both free and free, as it's distributed under the Creative Commons.
You can contact us and find show notes on our website, randomlytyped.com.
The intro music is by Vansky,
Thank you, Vensky.
and thank you, listener, for indulging us.